Welcome to the part 3 of the Pandas video series. In the past two videos, we have been talking about Pandas series and Pandas DataFrame. And today we are going to continue that topic and learn more about Pandas DataFrame. And in this video, we are going to fetch data from Pandas DataFrame without the loc and iloc indexers. Let's begin. So first of all, let me import pandas as pd, and next let's import data.csv file using pd.readcsv function and assign that to df variable. Let me press shift enter. Let me use df.head function to see the top 5 rows of data.csv. We can see that data.csv file has these columns that we can see: employee id, department salary, and till customer feedback. So this is the data that we will be dealing with today. First of all, for example, if I want to fetch one column from this data frame without using the loc and iloc indexers, we can use df and we can use a square of brackets, and then we can write the column name that we want to fetch from here. For example, I want to see salary column only. I will say df, inside a pair of brackets I can write the column name, and if I run this, we will see only a series here. Remember that each column in the data frame is a series, and that's why it's returning only a series. If I want to fetch more than one column, for example 2 or 3 columns, I need to add all the column names in a list. So for example, I need salary, and then after salary I want to see department, for example, and then I want to see work hours. If I press shift enter, it will return another data frame that has these 3 columns: salary, department, and work hours. We can not only fetch columns, but we can fetch rows as well. For example, let me comment this one, and let's add another line here: df. I can say give me from rows 0 to 5. Remember, we will not get row number 5 here, but only 0 to 4. If I press shift enter, we can see that 0, 1, 2, 3, and 4 are returned based on our query from this data frame. If I want to fetch only one row from this data frame, I can just define the range as, for example, if I want to fetch the first row, I can say give me row from 0 to 1. We understand that the last index is not included, so it will return only row number 0. If I press shift enter, it's returning row number 0 here. If we want to fetch a range of rows and then a range of columns, we can do that as well. For example, I want to fetch rows from 1 to 4, and then I want to fetch the columns. So for columns, I need to add another square of brackets, and then inside this I can say df.columns, and then I can specify the range of columns, for example 0 to 3. If I press shift enter, it will return rows number 1, 2, 3, 4 is not included, and then it will return columns 0, 1, 2. So column 0 is the employee ID, we can see above in this data frame. Column 1 is department, and column 2 is salary. Column 3 is again not included because the last index will be skipped. So this way we can fetch a range of rows and a range of columns without the iloc and loc indexers. We can also merge two methods. For example, we can select a few columns from a data frame, and then we can use the iloc indexer to define a range of rows to be selected from this data frame. For example, I can say df, and I can provide a list of column names. For example, I need department, comma, gender, and then I need meetings attended. So I need these 3 columns. If I press shift enter, it will give me all the data from the data frame, but it will give us only these 3 columns. Now I can filter this result with the iloc and loc indexers. For example, I can use iloc on this. I can change this. I can use the iloc, and then I can define a range. For example, I can say give me rows 2 to 8. If I press shift enter, it will give me rows 2 to 7. The last one is skipped, and it will give us these 3 columns. So we can merge these two methods to fetch a few columns from this data frame and then filter it based on indexes of rows. So we can get the result like this. We can also use iloc at the beginning and the second method at the end. For example, I can say df.iloc, and inside this square of brackets I can say 2 to 8. After that, I can use another pair of brackets, and inside that I can specify a list of columns like department, comma, salary. If I press shift enter, it will give me these two columns that we have selected, and it will give us only the rows that we have defined in this iloc indexer. So we can chain these two together. It's not a problem, and it will give us the proper result. Now that we are comfortable with getting data from a data frame, let's now use some advanced indexing for getting data from a data frame. The first advanced indexing question here is that, for example, someone asks to get the first 5 rows and then the 10th row and 12th row from this data frame. This is a question that might be asked in some interviews. For example, we want to get data from 0 to 4 rows, the first 5 rows, and then get data from row number 10 and row number 12, like this. So how can we do that? Let's do it here. For example, first of all, we need to prepare a list of these rows. Like I can say, give me a range of values 0 to 5. If I press shift enter, it will give us a range 0 to 5. If I convert this to list, it will give me this list. Now we already have this list, which is defined by this list and range functions. Now we can add another list to this, and we can add these rows manually. For example, we can say row number 10 and row number 12. If I press shift enter again, this will give us this extended list from 0 to 4 and then 10 to 12. So now we have this range, and we can supply this range to the iloc indexer to get data from these indexes only. So let me assign this to a variable like rows, and then let me press shift enter. So we have assigned this to this rows variable, and I can say df.iloc use rows as filter. If I press shift enter, it will give me only these rows. We can see that it is giving me the first 5 rows 0 to 4 and then row number 10 and 12. So this is how we can tackle this problem. Now the next question can be about columns. For example, someone is asking us in an interview to fetch only the first 5 columns and then that random column and that random column. So we can do that as well. For example, someone is asking us to fetch the first 5 columns, employee ID, department, salary, gender, and work hours, and then fetch meetings attended and projects worked on. So we need to fetch these 7 columns from these data frames. So what we can do is to, first of all, let's list the columns, df.columns. If I press shift enter, it is giving me all these columns. If I filter this, for example, I can say 0 to 5. It will give me the first 5 columns, employee ID, department, salary, gender, and work hours. So these are the first 5 columns. If we convert this to list again and see this, now we have a list of these column names, and now again we can extend this list by adding the 2 more columns manually. For example, I can add meetings attended, comma, projects worked on. If I press shift enter, now we have a list of all these columns that we need data for. So we can just assign this to a variable calls, and if I press shift enter, it will create this list and will assign that to calls variable. Now we can use this calls variable to filter this data frame. I can just pass this calls variable to df, and if I press shift enter, it will give me the data of the data frame for these 7 columns only. So this is how we get data for 7 columns, where the question is that to select the first 5 columns and then manually add meetings attended and projects worked on columns. Now we can go further and we can just filter this for some rows as well. For example, I can select the first 5 rows with the iloc indexer, and I can pass this range 0 to 5. If I press shift enter, it will give me only the first 5 rows for those 7 columns that we are selecting from the data frame. Another question can be to combine the index-based and label-based data retrieval in the data frame. We can do that as well with the loc indexer. For example, I can say df.loc, and inside this square of brackets, I can just provide 2 lists. For example, I need row with index number 1, row with index number 4 and 6, and then I can provide a list of column names, and I can say give me department, comma gender for these rows only. So I can just provide two lists, df.lock indexer. The first list contains indexes, which is index based data retrieval, and the second list contains names of the columns, which is label based data retrieval. If I press shift enter, it will give me all the data that we are requiring here. It gives department and gender columns, and it gives 1, 4 and 6 rows. So this is how we can solve these problems whenever asked in interviews. I think we have learned a lot about data retrieval from the data frames. Let's talk about two of the data frame attributes as well. One is the size of the data frame and another is the shape of the data frame. Let's understand this. For example, if I say df.shape, it's an attribute, not a function. If I press shift enter, it's returning this tuple which has 20,9 values. This means that there are a total of 20 rows in this data frame and a total of 9 columns in this data frame. So a shape gives us rows and columns of a data frame. Similarly, there is another attribute, that is df.size. If I press shift enter, it gives us the total size of this data frame, and that is the total values that this data frame contains. So for example, if we multiply 20 by 9, it will give us 180. That means there are 20 rows, 9 columns, and if we multiply them, it will give us 180 values. So this data frame contains 180 values in different rows and column combinations. As we saw the attributes, we have some functions as well. For example, we can get the minimum value of the data frame, we can get the maximum value, and we can get the mean values or the average values. For example, if we talk about df.salary column, it is a series in this data frame which contains these values that you can see. If I want to see the minimum value here, I will run minimum function on it like this, and it will return the minimum value that this series contains. Similarly, I can check for the maximum value. If I press shift enter, the maximum value is 72,408, and we can also check the mean as well. When I run this statement, it gives me an error, and the error is because the values in this salary column are actually strings and not integer values, so it cannot calculate the mean of these values. We will tackle this problem later on. Let's first talk about minimum and maximum again. We can use the minimum function on a range of values or a data frame as well. For example, I can say df.lock. I can just fetch all the rows. If I press shift enter, it's returning everything, but I want to fetch only a few columns, not everything. So I can just provide it a list, and I can say give me department. If I press shift enter, it's only giving me department, and from here if I chain it with the min function, it will give us the minimum value in this department column, which is based on the alphabets. So if I change department to salary, and if I press shift enter, it's again giving me the minimum value. I can also add multiple columns, for example salary and department. If I press shift enter, then it will give me the minimum value of both columns. For salary it's 50,000 something, and for department it's engineering. So we can use minimum function on a data frame as well, and it will return a series as the result, where it will give us the minimum value for each column that we are specifying here. Similarly, we can just use a specific range here. For example, I can use 0 to 10, and if I press shift enter, it will filter for this 0 to 10 data frame, and inside that data frame it will give us the minimum and maximum values. Let me make it 0 to 3 and press shift enter. Now we can see that the result is changed. Salary is 57,000, department is HR. And of course, we can use minimum and maximum as well. If I press shift enter, it will give us the minimum and maximum values on this data frame. Let's now get back to the mean function and see why mean is not working on the salary column. So if I say df.salary.mean, it's giving me this error that we saw before as well. And this is because the salary column, if we see, it contains values as strings. If I check the type of this, for example, let me check the type Of course, it's a series, but if we check it with the .info function, it says that the type is object and object is actually a string. So that's why we cannot run mean function on this salary column. To tackle this problem, we can use some other functions to first convert this column to integer, and we need to convert all the values to integer, and then we can run mean on that. First of all, I can use the stript function to remove any leading and trailing spaces from this column. For example, I can say df.salary.str.strip. If I press shift enter, it will remove all the spaces from the values of this salary series and it will return a new series here. So let's assign this series back to df.salary so it can change the existing column. If I press shift enter, it will run this, will remove all the leading and trailing spaces and will assign the result to this df.salary column. But still, if we run df.salary.mean, it will still give us errors because it has a comma and a dollar sign. We can see that there are dollar signs and commas. So let's tackle this problem as well. Instead of running mean, let's again use the stript function for removing the dollar signs this time. df.salary.str.strip, and now we need to mention the dollar sign inside double quotes that we want to remove any leading or trailing dollar signs from this column. If I press shift enter, it returns all the values without dollar sign. So it basically removed the dollar sign from the beginning of all the values. Let's now assign this back to df.salary. Press shift enter, and now we are done with this as well. If we check df.salary.head, we can see that all the values do not have dollar sign at the beginning, but it still has a comma, and now we cannot use df.salary.str.strip for removing this comma because that's not in the beginning or end, it's in the middle. So we have another function for that, df.salary.str.replace. In replace function, we can replace one thing with another. So we can use comma and we can say remove this comma. So for removing that, we can replace it with nothing. If I press shift enter, it returns all the values and now it does not have any commas. So let's assign this back to df.salary. Press shift enter, and we are done with that as well. df.salary.head. We have values without dollar sign, spaces and commas. Now let's change the type of this, and let's use another function that is astype, and we can use int64 to change all the values from strings to int64 or to integer. If I press shift enter, all the values have been converted to integers, and now I can assign this back to the salary column, df.salary, to officially and formally change the type of all the values of df.salary column. If I press shift enter, we are done with that as well. With these steps applied, now we can use the mean function properly. We can say df.salary.mean. If I press shift enter, this time it's not complaining and it's just returning the mean of the df.salary column. I hope you have gotten the points. We can apply the mean function on different columns as well. For example, I can say df.loc. I can fetch all the rows, comma, and then I can specify some columns. For example, I can say salary column, work hours. Remember that the columns need to be numeric columns. Tasks completed. And then I can, if I press shift enter, it will return only these columns here that you can see. And here I can use the mean function on this resulting data frame. I can just say give me the mean of all these columns. If I press shift enter, it will give me mean for every column separately. And this is a result that is returned as a series. So we can see that salary has this mean, work hours mean is 7.11, task completed is 12.29. and so on. So we can use mean function on a column or a data frame, and we can chain other functions here as well. For example, if I want to sort these values, we have 61,000 on top, then 7, then 12. If I want to sort these values and return the result, we can use another function that is sort values, which is very important function. If I press shift enter, we can see that it is returning this result and the values are sorted here. We see the smallest values on top and the largest values at the end. And we can change this behavior as well. For example, if we want to see the largest values on top and the smallest values in the bottom, we can just add a parameter that is ascending is equal to false. And if I press shift enter, we can see that it is now sorting these values in descending order. Now that we have seen sort values, let's apply sort values separately on a column. For example, I can say df.salary.sort values. If I press shift enter, it will return the result and all the values will be sorted. We can see that the smallest values are on top and the largest values are at the bottom. And again, we can just add the parameter ascending is equal to false, and it will return the result in the descending order like this. If we want to use sort values on a data frame, we can do that as well. For example, I can say df.sort values. If I run this, we will get an error because we have not specified any columns here. In the above row, we applied sort values on a specific columns. That's why it did not give us any error. But here we are using sort values on data frame, and we need to specify a column that will be used by sort values to sort the entire data frame. So here I need to use a parameter by, and I need to assign a column name here. For example, I can say salary. If I press shift enter, now it is sorting the entire data frame based on the salary column, and we can see this from this index. We can see that index number 12, the first row, because the smallest salary is in the row number 12. Then we see row number 6, 7, 11, 8, 17 and so on. So this data frame is now sorted by salary column, and we have used salary column in the by parameter. Again, we can pass the ascending parameter here, and we can assign false to this to see the result in descending order. If I press shift enter, now we can see that this data frame is sorted in descending order based on salary column. We can see that the largest salary is on top, and this is in row number 14. Then the second largest is in the second position, which is at index 19 and so on. So we can use sort values on a series or a data frame. I think that's enough for today. We learned a lot of things in this video. We learned advanced indexing, we learned some attributes and some functions in data frame. In the next video, we will continue working with data frames, and we will use some advanced topics to work with data frames in Pandas library. If you got value from this video, make sure you like it, leave your comments in the comment section and subscribe to the channel. Thanks for watching.